I've mentioned this a couple of times last time as I went over hypothesis testing. We will do some cases in a bit, but before I get to that, I want to talk about p-value. P-value is quite important in hypothesis testing. The reason why we kind of have an option other than confidence intervals is because it's the p-value. The P here stands for probability. What a surprise. There is a formal definition for p-value. And based on my experience, I've seen students have difficulties with that definition. So I won't get to it right away, but I'll use a couple of informal ones. So you sort of get an idea as to what it is. The first informal definition . Because at the end of the day, interpreting p-value is more important than finding the number. So p-value is the probabilistic support toward the null based on current evidence. Current evidence would simply be your sample. How much support do you have toward the null hypothesis? The conclusion of a statistical test from last time is one of two things. We either reject the null or we do not reject the null. So if this probability is, say, as an example, .9922, would you reject the null? Hannah?
No.
Why not?
Because it's the support of the null. So
Because it's support of the null. So that's close to 900%. 99.22% support towards the null. And is it be foolish for us to reject the null? Does that make sense? Definition one, or informal definition. The second definition, we know what a type 1 error is from last time. What is a type 1 error? You can look at your notes.
It's the A. It says A.
It's a fish.
Yeah.
Yeah, alpha. But what does it mean?
Huh?
It is, Matthew.
Type 1 error is when you run the test and it says you not check the null hypothesis, but then some like truth or whatever that came up with that says to reject the null hypothesis. Basically, it's a false positive.
It's a false positive. So type 1 error pretty much is what occurs when you reject the null, when in reality you should not reject the null. So alpha is the maximum type 1 error we would like to set. So what is p-value? It is the probability It is the conditional probability of a type 1 error in rejecting null. Based on current evidence and assumption. In other words, it is the conditional probability of a false positive in rejecting the null. Why do we call it a conditional probability? Because this probability is conditioned on the fact that the null is true, because that is our initial assumption that the null is true, and we want to know how far the data takes us away from the null so that we can reject the null. So let's say I have a value (0.0179). Probably make a note here. In this case, we should not reject null. Here, you can tell me. Should I reject the null or could I reject it?
Yes.
One.
Because it's less, or it's just about 1%.
It's just about 1% chance. So the probability that I would be making that type 1 error conditioned on the data that I have and my current assumptions is about 1.79%. That's not a whole lot. If you use the same logic over here, 99.22%. Should you make a conclusion of rejecting the null if the probability of error is 99.22%? Should you? Would you? You should. So in this case, I can reject the null because the probability that I would be wrong is only about 1.79%. Do we understand these two informal interpretations? Yes.
So basically, like, you should not reject it if it is a high percentage.
That is correct.
Okay.
So you should put two and two together. It shouldn't be a high percentage. Now you may say, how high is high, right? Let me answer.
Okay, so how is that a type 1 error?
Come again?
How would that be a type 1 error? Would it be a type 1 error?
Rejecting the null. It wouldn't be. So if I rejected the null here, then the probability of a type 1 error is 99.22%. Here, I can reject it because it's only about 1.79%. Good. Now, one of the reasons why we wanted to come to hypothesis test is alpha is always subjective, correct? One person might say 5% is okay. Another person would say 1% is what we want. So p-value simply is a probability. If you find this acceptable, go for it, right? For me, this is good enough. Typically, the smaller the p-value, the more support you would have toward the alternative. So anything less than 0.05 or 0.01 is good to reject. Golden rule of thumb. Where am I picking the 0.05 and 0.01 from? The value of alpha. Do we understand the informal ones? Now comes the formal.
Wait, you said the p-value was what? Or was
P-value is the probability of a type 1 error in rejecting the null.
What if it's like 50%?
You can't reject. Why are you making that face?
Say that again?
It is the conditional probability of a type 1 error in rejecting the null. Suppose I reject the null. What is the probability that I would be wrong in doing that? The chances in this example is about 1.79%.
Oh, okay, gotcha.
So I can narrowly reject the null. So, well, if the informal ones are giving you this much trouble, here comes the formal one. Isn't life great? Yes. So p-value, the formal way of defining, is the probability of observing an outcome. Outcome in the sense simply conclusion or a test statistic. We will talk about that when we get to the problem. As extreme or more extreme in rejecting the null based on the sample that you have and the assumption that the null is true. Does that make sense? Go ahead.
Oh, no.
Let's say the null is over there, right in the middle. Last time we did mu less than or equal to something like that. Alternative would be greater than 2. Yes. So the null is mu less than or equal to 2. So in order to reject the null and go with the alternative, should you go in the right, toward the right or the left? Left. Got 2 more tries. Right. Is he right? If I have to go against this statement that mu is less than or equal to 2, let's say that value is 2, because that's my reference point. If I have to conclude that mu is actually bigger than 2, would I go to the right or to the left? To the right, right? Let's say there is some cutoff over there. That's what's going to help me make that decision. Call it point. Decision point, the fancy name for it is a critical value. you get the data and the data puts you right here. So based on the data, should you reject the null? Yes, because if it fell over here, I'm not going to reject the null. Anything past my decision point, I am going to reject the null. Good, with me? Now, the probability of observing an outcome as extreme, that's the extreme part, or more extreme, in other words, you are getting more evidence to reject based on the sample and assumption is the p-value. Suppose this p-value happens to be 0.9922. Good. So the probability of me seeing a similar outcome, such as this one, would be 99.22%. Good. If it is extreme or more extreme. So what we're trying to say is whatever happened purely by chance. There is no underlying effect whatsoever. It just happened because of pure randomness. If there is a true effect, whatever happened in getting this conclusion would not have happened in a random manner. There is an underlying effect that put us in the rejection region over here. In other words, there was a true effect that put us over there. That case would be the second case that we did, where the value was 0.0179. So if I collected another sample, because that's what we do, you go for a blood test, say you got a positive result for some condition, you want to verify it, yes? And when you verify it, you get positive again, what would you do? Verify it one more time. So the third time you get positive, what would you do? You can keep trying, but no matter how many times you try, if it keeps on coming positive, what does that tell you? You have whatever condition that you are becoming positive for. That said, the first time I rejected, and I'm going to say that the probability that it happened without no underlying rhyme or reason is 0.0179. There is only a 1% chance, approximately 2% chance, that I rejected the null without any underlying cause or reason. Yes? Does that make sense? Would you consider that there is an effect if I make that conclusion? Absolutely, right? Because I rejected, because there was an underlying effect, the true effect. And what are the chances that there was no underlying effect? It's only about 1.79%. So the right thing to do would be to reject. Does that make sense? That's what we mean by extreme or more extreme. But this applies to the other tests also. If you switch that decision point from the right-hand side to the left-hand side, instead of going far to the right, you'd be going towards the left. And if it is a two-tailed test, you're going to go far away from the center. So either way, you're taking, an extreme direction, right, left, or both sides. Does that make sense? And as Rebecca put it at the beginning, the bigger the p-value, If the p-value is large, you shouldn't be rejecting the norm. That's the underlying rule of thumb. So typically, if the p-value goes below 5%, we will reject the norm. However, in practice, the smaller the p-value, the better it will be.